Hello, everyone in CPE 333. I've been getting a lot of questions about the pipeline, Lab 1, and I'm here to try to help and um, give you guys some tips. So, a lot of you are wondering, how am I going to get from this to this? And the answer to that is you kind of go through it one step at a time and pay attention to where these dotted lines are. So, the first thing I would look at is the FSM, right? And don't worry about interrupts right now, at least. I'm not using that as what you should pay attention to are these control signals, all right? Because all the logic from this FSM has to go into the decoder. Because you're not going to have an FSM anymore. Your pipeline is going to become your FSM. So let's start with PC write. PC write is always going to be high in our pipeline. Why is that? Because we are fetching a new instruction every clock cycle, always high. Reg write, that's going to depend on the instruction. If you're writing to a register in that instruction, you want reg write to be high. Same with mem write. Mem read 1, always high. Again, you're fetching a new instruction every clock cycle, right? Mem read 2, that's going to depend. So, once you have all the logic in your FSM into your decoder, I would take a look at the other diagrams and notice a few things. So first of all, notice that this memory, these two memory modules, the dotted line goes through them. What does that mean, you ask? Well, it means that you shouldn't put this IR signal into a pipeline register. I made that mistake myself. It messes things up. Because your memory reads and writes on the positive edge, it's essentially acting like a register. Now that being said, notice how the register file is smack in the middle of the decode state. And also notice this little triangle here indicating a clock. Right now your register file is reading and writing on the positive edge of a clock. Wait a minute. We just said that that makes it act like a register and delays the signal. It does. That's a problem. Since we want this information to flow through the register file within one clock cycle in the decode stage, we need to change the way our register file works. And so what we're going to do is have the register file read in these IRs on the positive clock edge, and then we're going to write out these RS1 and RS2 values on the negative clock edge. That's going to save us. So once you have those kind of figured out, now you can start building your pipeline registers. So Dr. Kindness gives you a template with a structure to hold your registers in. That's going to help keep things organized. Think of it, you can kind of visualize it as if there's registers on each of these dotted lines, right? So every signal that crosses over this dotted line has to get stored in a register so that it can be used in this state. Otherwise, you're going to be using values. Let's say this is a, let's say this is an add, and this is a subtract, with different register values that you're reading and writing to. you don't want to be using this subtract instructions registers in this stage. So everything has to be stored in these registers. That's the whole point. And the information is going to get passed through those registers in the pipeline. You also need to pass through control signals, these control signals, and pay attention to where they're being used. So like, for example, you don't need to pass your ALU function all the way to the write back state. You're only going to need it up until the execute state, where the ALU is. So pay attention to that. Yeah, once you get that figured out, and you have all your signals getting passed through the pipeline registers, there's going to be a couple other things. You're going to have to handle hazards, and you're going to have to handle branches. First things first, I would handle branches. You can always add no ops.